problem we have here today is define each graph in regards to whether it is even, odd, or neither. To start off, what exactly is an even graph? Well, an even graph is best described by the equation f of x equals f of negative x. In a sense that if you were to replace the x's in the equation with a negative x, you would get a equivalent kind of equation, because this describes a reflection over the y-axis, and even functions or even graphs are attributed with the idea that they are reflected over the y-axis. So the first problem we have here today is f of x equals the absolute value of x. So looking at the graph, we see that if we were to reflect over the y-axis, the left side would land perfectly straight onto the right side, meaning that if it were to reflect over the y-axis, it would be a perfect reflection over. So this is an even graph because an even graph is best described as being a graph where if you were to reflect over the y-axis, it would be a clean cut and perfect reflection. To continue on with the lesson, the second part of the lesson is basically describing and defining an odd function. An odd function is best defined by the equation f of x equals negative f of negative x, meaning that there is a reflection over the x-axis and y-axis. So looking at this graph, f of x equals x to the 5th power, we can see that there is a reflection, or we can see that if we were to reflect it over the y-axis, we would get this. And it is not a perfect clean cut or perfect reflection over onto the right side, meaning that this is an odd function. But to confirm that it is an odd function, we must see the reflection over the x-axis next. So if you were to reflect it over the x-axis, you would also get the same thing, meaning that this is indeed an odd function. Looking at the third problem, or problem C, we have the equation f of x equals x squared plus 1. So to validate whether or not it is an even or odd function, we do the y-axis reflection and x-axis reflection test. So if we were to reflect this graph over the y-axis, we would get this. And clearly, that is not the same function or the same graph as f of x equals x squared plus 1. So this is neither an odd or even function, because also, if we were to reflect it over the x-axis as well, it would not work as well. So this is a neither function. So to sum it all up, when looking at the exponents of an equation with different polynomials, if you have f of x equals f to the nth power, if n is even, then your graph will be even, and if your n is odd, then your graph will be odd. Additionally, there is also one instance where a graph can be both even and odd. For example, if a graph were to be f of x equals 0, that would be an even and odd graph, because taking a look at the line 0, if you were to reflect it over the y-axis, or the x-axis, you would get the same exact function. And if you were to reflect it over the y-axis, you would also get the same exact function. So one of the only instances where f of x is both even and odd is where it equals 0.